following explains how to add 10 kilowatts to a single-family dwelling load calculation using code based on user input. The code utilizes a conditional statement to determine whether to add the additional load. This is useful for accounting for increased lighting loads in households where the user indicates they have a wife. This adjustment may be necessary to ensure that the electrical system is adequately sized to handle the expected demand. The code starts by prompting the user with the question, "Do you have a wife? Y/N." This input is stored in the variable wife. Next, an if statement checks if the value of the wife variable is equal to y. If it is, meaning the user answered yes, the code executes the statement SFD load plus equals 10. This statement adds 10 kilowatts to the existing SFD load variable, representing the single-family dwelling load. If the user enters anything other than y, the code skips the if statement and the single-family dwelling load remains unchanged. Consider the implications of this approach. Adding a fixed 10 kilowatts based solely on marital status may not accurately reflect the actual lighting load. A more precise approach would involve assessing the total square footage of the dwelling and applying a load factor based on the area, as specified in the National Electrical Code (NEC). The NEC provides guidelines for calculating general lighting loads based on the square footage of the dwelling. For example, NEC section 220.12 specifies a minimum lighting load of 3 volt-amps per square foot for dwelling units. To calculate the general lighting load, multiply the square footage of the dwelling by 3 volt-amps per square foot. Then, divide the result by 1000 to convert the load to kilowatts. This calculation provides a more accurate estimate of the actual lighting load. In addition to general lighting, the NEC also requires calculations for appliance circuits. NEC section 220.11 requires a minimum of 220 ampere small appliance branch circuits for the kitchen and dining areas. Each of these circuits is calculated at 1500 volt amps. This results in a total of 3000 volt amps or 3 kilowatts for small appliance branch circuits. Furthermore, NEC section 220.52 requires a minimum of 120 ampere laundry circuit. This circuit is also calculated at 1500 volt amps or 1.5 kilowatts. After calculating the general lighting load, small appliance branch circuit load, and laundry circuit load, a demand factor may be applied to the total load. NEC section 220.42 allows a demand factor of 35% to be applied to that portion of the general lighting load that exceeds 3 kilowatts. This demand factor recognizes that not all lighting and appliances will be in use simultaneously. To apply the demand factor, subtract 3 kilowatts from the general lighting load. Then multiply the remaining load by 0.35. Finally, add the result back to the 3 kilowatts to obtain the demand load for general lighting. The NEC also provides guidelines for calculating the load for individual appliances, such as ranges, dryers, and water heaters. NEC section 220.54 provides demand factors for household electric ranges, wall-mounted ovens, counter-mounted cooking units, and other household cooking appliances individually rated more than 1.75 kilowatts. The demand factors vary depending on the number of appliances. For example, for a single range, the maximum demand is 8 kilowatts. For 2 ranges, the maximum demand is 11 kilowatts. For 3 ranges, the maximum demand is 14 kilowatts. NEC section 220.55 provides demand factors for electric clothes dryers. The demand factor is 5 kilowatts or the nameplate rating of the dryer, whichever is larger. NEC section 220.53 provides demand factors for household electric water heaters. The demand factor is 100% of the nameplate rating of the water heater. In addition to the loads mentioned above, the NEC also requires calculations for heating and air conditioning loads. NEC section 220.51 requires that the heating and air conditioning load be calculated based on the nameplate rating of the equipment. The larger of the heating or air conditioning load is then added to the total load. After calculating all of the individual loads, they are added together to obtain the total calculated load for the dwelling. This total calculated load is then used to determine the size of the service entrance conductors and the overcurrent protection devices. It is important to note that the NEC provides minimum requirements for electrical installations. Local codes may have additional requirements. Always consult with a qualified electrician to ensure that the electrical installation is safe and compliant with all applicable codes. The code provided initially offers a simplified approach. To refine the load calculation, consider replacing the conditional statement with a more comprehensive assessment of lighting and appliance loads based on square footage and the number of occupants. Gather more information about the dwelling. Ask about the square footage of the dwelling, the number of bedrooms, and the types of appliances that will be used. Use this information to calculate the general lighting load, small appliance branch circuit load, laundry circuit load, and individual appliance loads according to the NEC guidelines. Apply the appropriate demand factors to these loads. Add the resulting loads together to obtain the total calculated load for the dwelling. Base the service entrance conductor and overcurrent protection device sizes on this total calculated load. Remember that electrical codes and standards are subject to change. It is essential to stay up to date with the latest requirements to ensure safe and compliant electrical installations. Always consult the latest edition of the NEC and any applicable local codes. A qualified electrician can provide guidance on how to properly calculate electrical loads and size electrical equipment. Moreover, the initial code example lacks error handling and input validation. It assumes the user will enter either Y or N. If the user enters any other value, the code will not function as intended. To improve the code, add error handling to ensure that the user enters a valid input. This can be done using a while loop that continues to prompt the user for input until the valid value is entered. For example, the code could be modified as follows: while wife equals Y and wife equals N wife equals input. Do you have a wife? Y/N if wife equals Y and wife equals N, print invalid input. Please enter Y or N. This code will continue to prompt the user for input until they enter either Y or N. If the user enters an invalid value, an error message will be displayed. Furthermore, the code does not provide any feedback to the user about whether the 10 kilowatts were added to the single-family dwelling load. To improve the code, add a print statement that informs the user of the action taken. For example, the code could be modified as follows: if wife equals Y SFD load plus equals 10, print adding 10 kilowatts to single family dwelling load, else print single family dwelling load remains unchanged. This code will display a message indicating whether the 10 kilowatts were added to the single family dwelling load. The NEC also addresses voltage drop in branch circuits and feeders. Excessive voltage drop can cause lights to dim, appliances to malfunction, and motors to overheat. To minimize voltage drop, conductors should be sized appropriately for the load and the distance they will carry the current. NEC Section 210.19 AM provides guidelines for sizing branch circuit conductors to minimize voltage drop. The NEC recommends that the voltage drop on branch circuits should not exceed 3%. NEC Section 215.2 A3 provides guidelines for sizing feeder conductors to minimize voltage drop. The NEC recommends that the voltage drop on feeders should not exceed 3%. Total voltage drop on both branch circuits and feeders should not exceed 5%. To calculate voltage drop, use the following formula: voltage drop equals 2 *k * d/cm, where k is the direct current constant, which is 12.9 ohms for copper conductors and 21.2 ohms for aluminum conductors. I is the current in amps, d is the one-way distance in feet, and cm is the circular mil area of the conductor. The circular mil area of a conductor can be found in NEC Chapter 9, Table 8. After calculating the voltage drop, compare it to the recommended limits. If the voltage drop exceeds the limits, increase the size of the conductors. In addition to voltage drop, the NEC also addresses overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating due to excessive current. NEC Section 240.4 provides guidelines for overcurrent protection of conductors. The overcurrent protection device should be sized to protect the conductor in accordance with its ampacity. The ampacity of a conductor is the maximum current that the conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on its size, insulation type, and installation conditions. Ampacity values for conductors can be found in NEC Table 310.16. When selecting an overcurrent protection device, choose a device with an ampacity that is equal to or less than the ampacity of the conductor. The NEC also allows for certain exceptions to this rule. For example, NEC Section 240.4b allows the next highest standard of a current protection device to be used in certain cases. However, the overcurrent protection device must not exceed the ampacity of the conductor by more than 100%. Consider also the impact of future load additions. The electrical system should be designed to accommodate future load growth. This can be done by oversizing the service entrance conductors and the overcurrent protection devices. In addition, consider installing a larger panel board with more available circuit breakers. This will provide flexibility for adding new circuits in the future. Remember that electrical work can be dangerous. Always take appropriate safety precautions when working with electricity. Turn off the power to the circuit before working on it. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. If you are not comfortable working with electricity, hire a qualified electrician. In summary, while the initial code snippet provides a simple way to add 10 kilowatts to a single-family dwelling load calculation based on marital status, a more accurate and comprehensive approach involves calculating the load based on square footage, appliance usage, and other factors as outlined in the NEC. Always consult with a qualified electrician to ensure that electrical installations are safe, code compliant, and adequately sized for current and future needs.